Hey folks, welcome back. In this video, we will be talking about Python random module. So it is mainly used to generate random data, shuffle data, and choose data from the sample of data. And it is mostly used in statistics and probability. So we use the following functions very frequently. Those are randint, random, choice, shuffle. So randint generates the random number between lower and upper limits, and random it generates the floating point between 0 and 1. And choice, we need to give a list or a sequence to it, and then it returns a random choice from it. And we have a shuffle. So when we pass the list of elements to it, it shuffles the list and it changes the order of the elements. So let's go to playground and start with randint function. So let me copy this and go to playground. First, we need to import the random model. So once we import the random model, we can use the functions from it. So let me use print statement here and pass, or let me use a variable for this result, and then result equals to random dot randint. So let's execute it. Python, we need to cd into random model. So once we do that, Python playground.py. So we can see that every time we run it, so we get a different number from between 5 and 15. So this is how we use randint. So we just need to pass start, that is lower bound, and upper bound. So whatever the random number that it generates, it is between the given numbers. Whatever the given numbers. In this case, it is 5 and 15. So let me clear the terminal and go to readme. So let's try out the random.random function. So let me loop through this, or okay, let me just replace this with this. Let's go to terminal and run it. So now we got 0.21. When we run it again, 0.78. When we run it again, 0.619, 0.94, so and so on. So every time we run it, so it generates a floating point number between 0 and 1. So that's how random.random function works. Let me go to, yeah. So here we have one more function, that is choice. So for this, we just need to give a list of numbers or list of any elements or a tuple of elements, whatever the sequence that we have. So it just generates the random choice from it. So let me copy this to playground and paste it here. So let me rename it as choices, and the choices equals to 1 2 3 4 5. Okay, so now we have everything ready, so we just need to run the code. So python playground.py. So once we run it, it randomly chooses a choice from the given iterable element, whatever it is. So once we run it, so now we got 5. When we run it again, we got 5 again. When we run it, this time we got 1, 5, 4, 5. So it's let me try this one more time. So we got 2, we got 3, we got 2, we got 5, we got 1. So it's just randomly choosing the number from it. So let me update this to names. Anji, John, uh, Krishna, David. So let me try this. So this time we got David, Krishna, Krishna, NG, Krishna, David. So it works just like that. So let me update this to a tuple instead of a list. Then also it should work. Let me try that. So we can see that it's working. And let me update this to a set. Okay, set object is not subscriptable. That's fine. So it's working for tuple list, and yeah. So that's how we use this random dot choice to choose option from the given choices. Okay, that's fine. Let me remove this and go back here. So we're done with run and random and choice. So let's look at this shuffle. So for this, we just need to provide a list of elements to it. It just shuffles it. So let me copy this sample code real quick and paste it here. Let me call it as a sample. Let's use uh, 100 as well. Result equals to, yeah. So now we are ready with the program. So we have a sample that is list, and then here we have a random shuffle. We are calling the shuffle function and passing the sample data to it, that is a list. So once we have it, we just need to uh, print result as well as the sample. So let me print the sample here as well. So this is before and this is after. So let me add a note before and after. Okay, so now we are ready with it. Let's run it. Let me clear this out and run python playground.py. So once we run it, for the first time we have 1 2 3 400, and the second for the result we got none because it's not returning anything. It's just updating the existing list whatever we pass. So it just updated the sample in this case. So 3 4 100 2 and 1. So it just shuffled the list that we passed. So whatever the things, the sample that we passed, that is in a sorted order. But when we look at the same sample variable, it has 3 4 100 2 and 1. So let's try one more time. So this time we got different shuffle, different again, different again, different again. So that's how we use this random dot shuffle to shuffle the things. So this shuffle function is mainly used when we have use cases like games, card game. So when we want to shuffle a deck of cards, and then we can use this shuffle function to shuffle it. So yeah, that's how we use this shuffle. So if we have any use cases, something very similar to that, and then we can use shuffle. So let's look at the other functions. So now we have completed all the most frequently used random functions. Let's look at the other random functions as well. Let's start with the seed function. So seed function takes a value and it sets it. So once it sets it generates the same sequence of random numbers whenever we set the seed value. So let me go to playground. So let's go here and remove this code. Let's keep the import statement. So let's set the seed value, random dot seed of 10. So we have set the seed. So once we done that, let's use for loop for index in range of 10. So we are generating 10 random numbers for the seed 10. So let me print it. Print random dot random. Okay, so let's run it. Python playground. So we got 10 values. So if we run it again, then also we will get the same sequence. So just let me run it again. So every time we run with the same seed value, so we get the same sequence of numbers. So here we can see that 0.571, 0.571, and 0.42, 0.4288, we have the same number, and we have all these uh, have the same sequence order. So it's generating the same numbers when we set the seed value. So this is mainly used when we use unit test cases for random functions. And so let's say we have a random sample of data that we are trying to test with, and then we can generate the random sequence using the seed value, and we can test it. So let me clear this out and go to the same function. So let's use the print statement, one more print statement here again, and let's check for one more case. Seed equals to 4 5, and let me copy this and paste. Seed equals to 10. Let's use the same code. -45. Let's clear this out and run Python playground. So here we have for seed 10 we have these values, and for seed 45 we have these values. So let's run one more time. So it generated the same sequence numbers. So we can see that for seed 45 we have here, so that is 2718 and all. So this is how we use the seed function to generate the same sequence of random numbers. Oh, oops. So that's how we use the seed function. And let's look at the uniform. So uniform, it generates the random floating number such that it has the lower and upper bounds, that is a and b. So every time it generates the number between these two numbers. So that is in this case it is 1 and 10. So let me copy this and try it in playground. Let me go to playground and remove all this stuff. So yeah, so result equals to random dot uniform of 1 to 10. So let me increase this to 100 and print result. Okay, so let's go to playground and run python playground.py. So this time we got 48.284. Let's try one more time. 25.95, etc., and then 94.4433 and something. So this is how we use the random dot uniform to generate the random numbers between the lower and upper bounds. It generates the floating point number. So that's how we use the uniform function. And let's look at the expo variate. Expo variate takes one parameter, that is lambda value, and it follows the exponential distribution to generate the random number. So let me copy the random dot expo variate and go to playground and remove this code, and result equals to expo variate and print result. Oops, result. Okay, yeah. So open terminal and run python playground.py. So we got 2.19, and second time we got 1.76, 1.56, 8.11, 0.4131, something like that. So it's generating the random number, random floating point number, but it's using exponential algorithm to generate it. Exponential distribution to generate the random number. So that's how we use expo variate, and we have gamma variate. So gamma variate takes two parameters, that is alpha and beta. So it follows the gamma distribution to generate the random number. So let's look at that. Let me copy gamma variate and go to playground. Just replace this with so here we can use any value, so whatever the value that we need. So here this time we are using gamma variate. So let me replace this with 1 and 5. So we can use any value. So that is all. This is alpha value and this is beta value. So let's try this out. Python playground. So we got 2.66, 6.51, 7.12, 2.7, 3.26, 4.02. So every time it's generating the different random number. So that's how we use gamma variate. Let's go here and let's look at the Gauss. So it takes the two parameters again. So that is mu and sigma. So it follows Gaussian distribution to generate the floating point random number. So let me copy this code random.gauss. So just replace this part of it. So this time we are using Gauss distribution. So 0 and 1. So this is mu and sigma. Let's execute it, clear this out and run python playground.py. So we got 0.12 minus 0.45, 0.23 minus 1.53. So it's generating the random numbers. So let's go here. So Gauss is done. Let's look at log norm variate. So it also takes two parameters, that is mu and sigma. So it follows log normal distribution. So it uses this distribution to generate the random number. So let's copy this to playground and replace this function here. So this time we are passing 1 and 2, but let's try to use 1.6 and run the code. So we got 2.41, 7.27, 7.96, 3.75, 65.52. So it's generating the different random numbers based on this log normal uh, distribution. So let's look at normal variate. Um, that also takes mu and sigma. So it follows normal distribution. So it follows normal distribution to generate the random data. So let me clear this out. Yeah, so let's copy this function and try it in playground. Let's replace this part of it, and yeah, so let's run python playground.py. So we got 0.89 minus 0.49, 1.01 minus 0.49. So it's also generating the different, what we call yeah, random numbers. So that's how we use the normal variate function to generate random numbers. And we have this one, Pareto variate. So it takes the alpha value and it generates the random number based on Pareto distribution. So let me try this out in playground. So let's update this function. So let's try it. So we got 8.5, 1.93, 2.00, 3.79. So it's generating the random numbers, but the algorithm, whatever it is being used, is different one, that is Apache distribution. So let's look at the sample. It takes the two parameters, that is population and k, that is number of elements that we want from the population. So generates a random sample of elements from a population without replacement. So it just, let's say we have given 100 elements and we want to pick 10 out of it. So and then we use this sample function to pick 10 elements from out of 100 elements. So let's look at this code to just replace this part of it. So this time we are using sample. So we are passing the sample as a list, and we want to take 3 elements out of the sample. Sorry, this is a population. Let me call it as population. Otherwise, it will be confusing for me. Population. Population equals to. Okay, clear this open brace. Okay, so now we have population. Okay, let's use 65, 34 ng. So we have the population with 1, 2, 3, 4, 5, 6, 7, 8 elements, and we want to pick 3 elements out of it. So let's try this out. Python playground.py. So we got 4134, we got 423, we got 652. Let's run one more time. We got 4651. Let's try one more time. Yeah, this time we got Anji 3, 4, and 5. Sorry, not 3, 4. Anji 3 and 5. So this is how we create a sample out of population using a random.sample function. So let's clear this out and go to README. We have one more function, that is triangular. So triangular distribution is a continuous probability distribution with lower limit, upper limit, and mode which represents the peak of the distribution. So we use this function to generate the random number, I guess. So let's copy this example, go to playground and remove this population thing and replace this part of code with the copied code. So here we have this triangular. So this 0 is the lower bound and 100 is the upper bound, and we have mode, that is 50. So mode means occurs multiple times. So whenever it generates the value, so which is nearer to this the mode that is given. So let's try that out. So Python playground.py. So we got 32, we got 25, we got 57, we got 68, we got 13. So most of the time it is it is nearer to the mode that is given. So we can see that. So when we generate the code, so we can see that it's generating the values. They are nearer to the what we call the mode. So look at this value: 44, 45, 51, 57, 54, 46, 46, so 58. So most of the random numbers that were generated, so they are nearer to this number, that is 50. So let's make this only 10 and try to generate value between, okay, let's make it one more very smaller. So let's try out 3 here. So let's clear this out. 4.4, 3.5, 3.15, 3.55, 1.4, 1.2, 3.6. So here we can observe that 3.15, 3.55, 3.36, 3.14. So most of the values that it generated, it is nearer to the mode value, that is 3. So yeah, that's how we use this triangular function to generate the random values. So all these functions uses a different distribution. Some follow, I mean, based on the function to generate the random number or a random floating number. So this is how we use all these functions to generate random values and create a sample from the population, and shuffling things, um, taking a choice out of a given population or given sample randomly, and generating random integers. And yeah, so that's all about the random module. If you find this video is useful, and then like the video, share it with your friends, and don't forget to subscribe to my channel. So I'll provide the reference links in the description. So keep rocking. Thank you.